You've seen them in viral videos, robots performing backflips, dancing to Do You Love Me, and navigating obstacle courses with uncanny human-like movement. They've made you laugh, made you uncomfortable, and maybe even made you wonder if the robot apocalypse is coming sooner than we thought. But what if I told you that these mesmerizing machines, once considered fascinating but financially frivolous research projects, are now at the center of one of the biggest bets in technology history? Just a few years ago, Google couldn't wait to offload this same company, believing these incredible robots had no viable commercial future. So what changed? How did Boston Dynamics transform from a YouTube curiosity into perhaps the most valuable robotics company on the planet? We're pulling back the curtain on one of the most fascinating pivots in tech history, the evolution of Boston Dynamics from an academic research lab to the cornerstone of Hyundai's vision for our automated future. Let's dive in. Imagine it's 1992. The internet barely exists. Most people don't own a mobile phone. And robots? They're either industrial arms bolted to factory floors welding car parts, or they're fantasies in science fiction movies like Terminator 2, which had just blown everyone's minds the year before. This is the world where Mark Rybert, an MIT professor with an unusual obsession, decides to start a company called Boston Dynamics. But Rybert wasn't interested in building better factory robots or creating the next Hollywood special effect. He was fascinated by something more fundamental and, at the time, seemingly impossible: movement. Everyone thinks robotics is about making robots do tasks, Rybert once said in an interview, but I've always been interested in how things move, the mechanics, the control systems, the intelligence that allows humans and animals to navigate complex environments with such grace and efficiency. This wasn't just an academic curiosity. Rybert understood something profound. If robots could move through the world the way living creatures do, adapting to uneven terrain, recovering from unexpected pushes, navigating crowds, they could escape the confines of structured factory environments and become truly useful in our messy, unpredictable world. But here's what makes Rybert's vision so remarkable. In 1992, the computational power, sensor technology, and mechanical engineering needed to realize this dream simply didn't exist. He was literally decades ahead of his time. For almost the first 15 years of Boston Dynamics' existence, the company operated in relative obscurity. They developed simulation software for interactive systems and worked on a handful of research projects. Nothing that would make headlines or attract millions of YouTube views. But all that was about to change, and it would start with a machine that looked like it came straight out of a sci-fi nightmare, powered by what sounded like a furious swarm of bees. The DARPA era and early innovations. When we talk about technological innovations that changed the world, many have an unexpected origin: military funding. The internet, GPS, microwave ovens, all began as defense technologies before transforming civilian life. Boston Dynamics would follow a similar path. In the early 2000s, America was engaged in wars in Afghanistan and Iraq. Soldiers were navigating mountainous terrain and urban environments while carrying up to 100 pounds of equipment. This was not only exhausting but dangerous, as tired soldiers made mistakes and suffered injuries. DARPA, the Defense Advanced Research Projects Agency, saw this problem and did what they do best: throw money at radical technological solutions. They wanted a robotic pack mule that could carry equipment across terrain too rough for vehicles. Most robotics companies proposed wheeled or tracked vehicles, essentially miniature tanks. Boston Dynamics had a different idea: a four-legged robot that could walk like a horse or mule, navigating the same terrain soldiers would traverse. In 2005, Boston Dynamics unveiled Big Dog, and nothing in robotics would ever be the same. Standing about 3 feet tall and weighing 240 pounds, Big Dog was powered by a two-stroke engine that sounded like a weed whacker having an anxiety attack. It wasn't pretty. It wasn't quiet. But when DARPA officials saw Big Dog recover its balance after being kicked on an icy surface, they knew they were looking at something revolutionary. Let me explain what made Big Dog so special. Traditional robots operate with what engineers call static stability. They're designed to maintain balance by keeping their center of gravity over their base of support at all times. Think of how you might carefully walk across an icy sidewalk with small, shuffling steps. Big Dog, however, employed dynamic stability, the same kind humans and animals use when we walk and run. We're actually falling forward with each step, catching ourselves with the next foot. This allows for faster, more efficient movement, but it requires constant adjustment and adaptation. To achieve this, Big Dog had an astonishing array of sensors and control systems. Force sensors in each foot measured ground contact. Inertial sensors tracked body orientation. Joint position sensors monitored leg movements. A gyroscope detected angular velocity. All feeding into algorithms that made split-second adjustments to maintain balance. This wasn't just a mechanical achievement, it was a triumph of integrated systems engineering. When videos of Big Dog recovering after being kicked went viral, public reaction was mixed. Some were impressed by the engineering. Others found it deeply unsettling. The machine's movements were too animal-like, triggering an uncanny valley response usually reserved for humanoid robots. But admiration or fear aside, everyone recognized they were seeing something new. Big Dog could carry 340 pounds, climb 35-degree slopes, traverse rubble, ford streams, and hike through snow, all while maintaining balance against pushes, kicks, and slippery surfaces. There was just one problem: that engine. Big Dog sounded like a demonic lawnmower, making it completely impractical for stealth military operations. Despite its impressive capabilities, DARPA eventually discontinued funding. But Boston Dynamics was just getting started. Their next creation was even more ambitious. If Big Dog was impressive for walking, what about running? In 2012, they unveiled Cheetah, a robot that could sprint at 28 miles per hour on a treadmill, faster than Usain Bolt's top speed of 27.5 miles per hour. Cheetah's design mimicked the flexible spine of real cheetahs, storing and releasing energy with each stride. This wasn't just copying nature, it was understanding the underlying principles that make cheetahs the fastest land animals and applying those principles to mechanical systems. But Cheetah, like Big Dog, was tethered to an external power source. For Boston Dynamics robots to be truly useful, they needed to be self-contained systems that could operate independently in the field. This challenge would lead to Wildcat, a free-running quadruped that could gallop at 19 miles per hour across flat terrain. Not as fast as the tethered Cheetah, but impressive considering it carried its own power supply and computing systems. Through these early projects, Boston Dynamics established their identity. They weren't building conventional robots, they were creating dynamic machines that could move through the world with animal-like agility. But they were still primarily a research company funded by military contracts, not a commercial enterprise building products for the mass market. This tension between cutting-edge research and commercial viability would define the next chapter of their story, a chapter that would begin with an acquisition that surprised the tech world. December 2013. The tech world is buzzing with a surprising announcement. Google has acquired Boston Dynamics. This wasn't an isolated purchase, it was part of a robotics buying spree led by Andy Rubin, the creator of Untold. In just 6 months, Google had acquired 8 robotics companies. The press dubbed this mysterious initiative Project Replicant, a nod to the androids from Blade Runner. Google was tight-lipped about their plans, but one thing was clear: they were making an aggressive move into robotics. For Boston Dynamics, the acquisition meant something they'd never had before: deep pockets and freedom from the constraints of military contracts. While DARPA funding had enabled their early innovations, it also tied them to specific military applications. Under Google, they could pursue broader visions. And pursue them they did, with their most ambitious project yet, Atlas. When Atlas was first unveiled in 2013, it was unlike anything the world had seen outside of science fiction. Standing 6 feet tall and weighing 330 pounds, this humanoid robot was initially designed for the DARPA Robotics Challenge, a competition focused on developing robots that could assist in disaster scenarios too dangerous for humans. The early Atlas was tethered to both a power cable and a safety harness. Its movements were slow and deliberate. But even then, you could see the potential. Atlas could walk over uneven terrain, climb stairs, open doors, and use tools, all fundamental capabilities for operating in human environments. What made Atlas truly special wasn't just its humanoid form, it was the control systems that allowed it to maintain balance while performing complex tasks. Think about how automatically you adjust your body when reaching for something on a high shelf or when someone bumps into you on a crowded train. These unconscious adjustments are incredibly complex from a robotics perspective. With each iteration, Atlas became more capable. By 2015, a new version eliminated the power tether, allowing Atlas to operate on battery power. By 2016, it had shrunk to 5 feet 9 inches and 180 pounds, about the size of an average human male but packed with sensors, hydraulics, and computing power. Then came 2017, and Atlas did something that dropped jaws worldwide: a backflip. Let me emphasize how extraordinary this was. Most humanoid robots at the time were struggling to walk without falling over. Atlas was performing gymnastics. This wasn't just an incremental improvement, it was a quantum leap that demonstrated Boston Dynamics' mastery of dynamic movement and balance. The progression continued at a remarkable pace. 2018, Atlas running outdoors and jumping over logs. 2019, a full parkour routine including jumps between platforms at different heights. 2020, a gymnastic routine that included running jumps, 360-degree turns, and split leaps. 2021, an elaborate parkour course with coordinated movements between two Atlas robots. Each video more impressive than the last, each demonstrating new capabilities in balance, coordination, and adaptation. But despite these technological triumphs, Google saw no gain because they didn't believe back in 2017. Google's parent company, Alphabet, was restructuring and focusing on profitability. The robotics division had lost its champion when Andy Rubin left Google in 2014. And critically, no one seemed to have a clear vision for how to turn these incredible machines into profitable products. While Atlas was wowing YouTube viewers, Google executives were asking tougher questions. How do we monetize this? What's the business model? When will these robots be ready for commercial applications? Boston Dynamics' focus on pushing the boundaries of what robots could do physically didn't align well with Google's need for near-term revenue. In 2016, rumors began circulating that Google was looking to sell Boston Dynamics. In June 2017, it became official. SoftBank, the Japanese conglomerate led by Masayoshi Son, had acquired Boston Dynamics for an undisclosed sum. Google's experiment in advanced robotics had ended less than 4 years after it began. But this change in ownership would catalyze Boston Dynamics' transformation from a research lab to a commercial enterprise, a transformation centered around their most successful robot to date. The commercial breakthrough, Spot. If Atlas represented Boston Dynamics' ambition, their next major robot would represent something equally important: practicality. Meet Spot, the robot that would finally bridge the gap between Boston Dynamics' cutting-edge research and commercial applications. Unveiled in 2016 and refined over the next several years, Spot was smaller and more practical than its predecessors. Standing about 2.5 feet tall and weighing 70 pounds, this quadruped robot could operate for 90 minutes on a single battery charge. More importantly, it was designed from the ground up to be useful across multiple industries. What made Spot different from Big Dog or Atlas wasn't just its size or design, it was the entire philosophy behind it. While earlier robots were technology demonstrations, Spot was a platform, a versatile tool that could be customized for different applications. Spot came equipped with 360-degree cameras providing stereo vision, LiDAR for accurate distance measurement, an arm attachment for manipulating objects, a modular payload system for additional sensors or equipment, semi-autonomous navigation capabilities, a user-friendly control interface, all packaged in a weather-resistant, durable form factor that could operate in environments ranging from construction sites to nuclear plants to offshore oil rigs. In 2019, Spot became Boston Dynamics' first commercially available robot, with a price tag of $74,500. While not exactly affordable for the average consumer, it was a price point that made sense for industrial applications where the robot could replace dangerous human labor or provide capabilities not otherwise possible. The market response was encouraging. Companies across sectors started integrating Spot into their operations. Construction firms like Pomelo used Spot to document site progress and identify safety hazards. Utility companies deployed it to inspect remote facilities and dangerous environments. Mining operations used it to map underground tunnels. Oil and gas companies sent it into areas with potential gas leaks. NASA's Jet Propulsion Laboratory tested it for potential Mars exploration concepts. Perhaps most surprisingly, during the COVID-19 pandemic, Spot found applications in healthcare. At Brigham and Women's Hospital in Boston, Spot robots equipped with iPad screens allowed doctors to conduct remote patient assessments, minimizing exposure risk. Boston Dynamics also opened up their software development kit, allowing customers to create custom applications. This transformed Spot from a product into a platform that could evolve to meet specific industry needs. By 2021, Boston Dynamics had sold several hundred Spot robots, not mass-market numbers, but a significant milestone for a company that had spent decades focused on research rather than products. Spot represented something crucial, proof that Boston Dynamics could create robots that were not just technically impressive but commercially viable. This wasn't just a research lab making cool demos anymore, this was a company building tools that solved real business problems. But Boston Dynamics wasn't content with just one commercial product. Their next robot would target one of the largest and fastest growing sectors in the global economy, logistics. Stretch and warehouse automation. Enter Stretch, Boston Dynamics' purpose-built solution for warehouse automation, unveiled in 2021. At first glance, Stretch looks less impressive than Atlas or Spot. There's no parkour, no backflips, just a mobile base with a long robotic arm ending in a vacuum gripper. But appearances can be deceiving. What Stretch lacks in acrobatic flair, it makes up for in practical utility. Here's what makes Stretch special. Its mobile base can navigate standard warehouse environments without requiring fixed infrastructure. The vacuum gripper can handle boxes of various sizes weighing up to 50 pounds. Computer vision systems identify boxes and plan optimal unloading sequences. The arm has 7 degrees of freedom, allowing it to reach deep into truck trailers or containers. It can move up to 800 boxes per hour, comparable to human workers but without fatigue. Most importantly, Stretch was designed specifically for the task of moving boxes, the fundamental unit of modern logistics. While that might seem narrowly focused, consider this: in the United States alone, billions of boxes are moved through warehouses every year, primarily by human labor. By focusing on this specific problem, Boston Dynamics targeted a massive market with clear return on investment potential. A company could calculate exactly how much they spent on human labor for loading and unloading, compare it to Stretch's cost, and make a straightforward business decision. This pragmatic approach marked a significant evolution in Boston Dynamics' business strategy. They weren't just creating impressive technology anymore, they were solving specific industry problems with clear economic benefits. With Spot demonstrating their ability to create flexible, multi-purpose robots and Stretch showing their commitment to industry-specific solutions, Boston Dynamics was positioning itself as a serious commercial entity, one that could translate cutting-edge research into practical applications. This transformation made them increasingly attractive to their next owner, a global industrial powerhouse with ambitions far beyond their traditional market. The Hyundai era and vision for the future. December 2020. As the world grappled with the COVID-19 pandemic, a major announcement quietly reshuffled the deck in the robotics industry. Hyundai Motor Group had acquired an 80% stake in Boston Dynamics from SoftBank, valuing the company at $1.1 billion. At first glance, it seemed an odd match. What did a Korean automotive manufacturer want with an American robotics company known for viral videos of dancing robots? The answer lies in Hyundai's broader vision. Under Chairman Yee-Sun Chung, Hyundai had been aggressively expanding beyond traditional automaking into what they call future mobility: electric vehicles, urban air mobility, flying taxis, autonomous driving, and yes, robotics. For Hyundai, Boston Dynamics wasn't just another acquisition. It was a cornerstone of a strategy to transform from a car company into a mobility and automation powerhouse. And unlike Google, Hyundai brought something essential to the table: mass manufacturing expertise. Hyundai is a company that has scaled complex mechanical systems successfully for decades, explains robotics analyst Sarah Johnson. They know how to take sophisticated machines from prototype to mass production while maintaining quality and controlling costs, exactly what Boston Dynamics needed. This partnership began bearing fruit quickly. By 2022, Boston Dynamics had accelerated the commercialization of Spot, expanded Stretch's capabilities, and continued pushing the boundaries with Atlas. Then came this week's bombshell announcement: Hyundai isn't just maintaining their investment in Boston Dynamics, they're quintupling down with a massive $6 billion infusion, part of a staggering $21 billion robotics initiative. This isn't just a vote of confidence, it's a fundamental repositioning of Boston Dynamics at the center of one of the largest industrial transformations in history. So what exactly is Hyundai planning? While full details haven't been released, their public statements and recent demonstrations provide some clues. First, they're accelerating development of the Factory Service Robot, FSR, a version of Spot designed specifically for industrial environments. These robots can perform automated inspection rounds in factories, identifying potential problems before they cause downtime. Second, they're scaling up production of Stretch for warehouse automation, positioning it as a key solution for the logistics challenges faced by companies worldwide. But the most ambitious aspect of their plan centers around humanoid robots, particularly advancing Atlas from a research platform to a commercial product. In March 2025, Boston Dynamics unveiled an electric-powered version of Atlas designed specifically for industrial applications. This newer, electric Atlas represents a significant evolution. It's smaller and lighter than previous versions. It's fully electric rather than hydraulic, making it quieter and more efficient. It's designed with manufacturing in mind rather than just research. It can perform precise manipulation tasks while maintaining balance. Why does this matter? Because humanoid robots offer something unique: they can operate in environments designed for humans. Unlike specialized industrial robots that require custom facilities, humanoid robots can theoretically work alongside humans, using the same tools, navigating the same spaces, and performing similar tasks. This could fundamentally change manufacturing economics. Currently, automating a new task often requires custom-designed machines and factory reconfiguration, expensive and time-consuming processes. A versatile humanoid robot could potentially be reprogrammed for different tasks without changing the physical environment. And Hyundai's vision extends beyond the factory floor. They've demonstrated concepts integrating robotics with vehicles. Imagine delivery vans with robot assistants that can carry packages to doorsteps, or rescue vehicles that can deploy robots into dangerous environments. Perhaps most ambitiously, Hyundai sees potential for robots in healthcare and aging support, critical needs in societies with aging populations like South Korea, Japan, and increasingly, the United States. Robots that could assist elderly or disabled individuals with mobility and daily tasks could transform quality of life for millions. What's remarkable about Hyundai's approach is its comprehensive nature. They're not just betting on one robot or one application, they're building an ecosystem of robotic solutions ranging from specialized industrial machines to versatile humanoids, all supported by advanced AI, manufacturing infrastructure, and global distribution networks. This ecosystem approach addresses what has historically been robotics' greatest challenge: scaling from impressive demos to practical, widespread deployment. The competition and industry landscape. Boston Dynamics may be the most recognizable name in advanced robotics, but they are far from alone. As the potential market for versatile robots grows, competition is intensifying from both established players and ambitious startups. On the humanoid front, Figure has emerged as a formidable competitor. Their Figure robot, while less acrobatic than Atlas, has demonstrated impressive manipulation capabilities and a clear focus on commercial applications from the start. In early 2025, Figure announced a partnership with BMW to deploy their robots in manufacturing facilities, a direct challenge to Hyundai and Boston Dynamics. Tesla, never one to be left out of a technological revolution, unveiled their Optimus robot in 2022. Initially met with skepticism after a person in a robot costume appeared at the announcement event, Tesla has since demonstrated functioning prototypes. Elon Musk has made characteristically bold claims about Optimus eventually costing less than $20,000 and becoming a mass-market product. The advantage Tesla brings to robotics is vertical integration, explains robotics professor Dr. James Chen. They control everything from AI development to motor design to manufacturing. That could allow them to optimize the entire system in ways other companies can't. In the quadruped space, Chinese company Unitree has been producing dog-like robots at a fraction of Spot's price. Their B2 model costs under $10,000 compared to Spot's $74,500. While these robots have fewer capabilities than Spot, they found a market among researchers, developers, and even some commercial applications where cost is a primary consideration. This competitive landscape creates both challenges and opportunities for Boston Dynamics. The challenge is clear: they're no longer the only game in town when it comes to advanced, versatile robots. Other companies are pursuing similar visions, often with more focused commercial strategies from the start. But the opportunity is equally clear: Hyundai's massive investment provides resources that few competitors can match. Combined with Boston Dynamics' technical expertise and Hyundai's manufacturing prowess, this partnership could accelerate deployment at a scale that would be difficult for startups to achieve. What's particularly interesting is how different companies are approaching the market with different priorities. Boston Dynamics emphasized capability first, then commercial applications. Figure focused on commercial applications from the beginning. Tesla leveraged their AI expertise from autonomous driving. Traditional robotics companies build on their industrial experience. This diversity of approaches suggests we're still in the early stages of the robotics revolution. No single model has proven definitively superior yet. The road ahead, challenges and opportunities. Despite the impressive capabilities of today's robots and Hyundai's massive investment, significant challenges remain before Boston Dynamics' vision of versatile, helpful robots becomes mainstream reality. Technical challenges come first. While the viral videos are impressive, they represent carefully controlled demonstrations. Operating reliably in unpredictable real-world environments remains difficult. There's a big difference between a robot performing a pre-programmed routine in a known environment versus adapting to unexpected situations in the real world, explains robotics engineer Dr. Sarah Wong. The YouTube videos show what's possible under ideal conditions, not what's practical in everyday use. Economic challenges are equally significant. Advanced robots remain expensive to produce. A single Atlas robot likely costs hundreds of thousands of dollars to build, fine for research but problematic for widespread deployment. Even the more practical Spot starts at $74,500. Hyundai's manufacturing expertise could help address this, but achieving the kind of cost reductions that would make these robots truly mainstream will require fundamental innovations in design and production. Then there are regulatory challenges. As robots move beyond factories into public spaces, questions about liability, insurance, certification, and operational standards become increasingly important. Who's responsible if a delivery robot injures someone? What safety standards should apply to care robots working with elderly patients? Many of these regulatory frameworks simply don't exist yet, creating uncertainty for companies investing in robotics development. But alongside these challenges are enormous opportunities. The global market for professional service robots exceeded $13.1 billion in 2023 and is projected to reach $87 billion by 2030. As labor shortages persist across developed economies and wages rise, the economic case for robotics strengthens. Healthcare presents particularly compelling applications. Japan and South Korea, facing rapidly aging populations and shrinking workforces, are investing heavily in robots that can assist with elder care. Robots that could help lift patients, deliver medications, or even provide companionship could transform care for millions of seniors. Manufacturing is another sector ripe for transformation. Despite decades of automation, many manufacturing tasks remain manual because they require dexterity, judgment, and adaptability that traditional robots lack. Humanoid robots could potentially fill this gap, handling complex assembly tasks that have resisted automation. Perhaps most intriguingly, Boston Dynamics robots could find applications we haven't even imagined yet. Just as few predicted that smartphones would transform everything from how we navigate cities to how we date, versatile robots could enable entirely new services and capabilities. When a technology becomes sufficiently capable and affordable, entrepreneurs find applications the original inventors never conceived, notes tech historian Dr. Robert Lee. We saw it with personal computers, the internet, smartphones, and will likely see it with advanced robotics. This combination of challenges and opportunities makes Boston Dynamics' journey, and Hyundai's massive bet on them, one of the most fascinating stories in technology today. They're not just developing cool robots, they're potentially laying the groundwork for the next major technological revolution. Boston Dynamics' evolution from MIT Research Lab to YouTube sensation to the centerpiece of Hyundai's $21 billion robotics initiative encapsulates the broader story of robotics itself, a field transforming from science fiction to fundamental technology. Their journey reminds us that true innovation often requires patience. For nearly 30 years, Boston Dynamics has pursued a singular vision, creating machines that can move through the world with animal and human-like agility. They've persisted through multiple ownership changes, shifting business models, and evolving market conditions. What makes their story particularly remarkable is how they've balanced technical ambition with increasing commercial focus. They haven't compromised their vision of creating genuinely capable robots, but they've found ways to translate that vision into products that solve real problems. Hyundai's massive investment signals a new chapter, not just for Boston Dynamics but for robotics as a whole. It suggests we're moving from the research and development phase to the deployment and scaling phase. The question is no longer can we build capable robots, but how do we integrate these robots into our economy and society? The answers to these questions will unfold over the coming decades, shaped by technical progress, economic factors, regulatory decisions, and social responses. But one thing seems increasingly clear: the robots that once seemed confined to science fiction are becoming reality, and Boston Dynamics is leading the way. Whether Hyundai's $6 billion bet pays off remains to be seen. But regardless of the commercial outcome, Boston Dynamics has already secured its place in technological history, proving that with enough vision, persistence, and engineering brilliance, even the most ambitious ideas can become reality. This incredible journey from research lab to multi-billion-dollar acquisition target raises so many fascinating questions about our robotic future, and I'd love to hear your thoughts. Do you think Hyundai's massive investment in Boston Dynamics is visionary or excessive? Would you be comfortable working alongside a humanoid robot like Atlas? Which applications of these robots excite you most, and which concern you? Drop your thoughts in the comments below. I read every comment and love engaging with this community of technology enthusiasts. If you found this deep dive into Boston Dynamics informative, please hit that like button. It really helps the channel. And if you're fascinated by cutting-edge technology and want more videos exploring the intersection of innovation, business, and society, subscribe and ring that notification bell. I'm planning a whole series on robotics and automation, including deep dives into Figure, Tesla's Optimus project, and the ethical implications of increasingly capable machines. Let me know which aspects of this robotics revolution you'd like me to explore next. Until then, time and thank you for joining me on this journey into the future of robotics. Remember, the future isn't just coming, it's doing parkour.